An airplane preparing to land estimates the angle of depression to each end of the 6,000-foot runway is 12 and 15 degrees. Determine the length of the line of sight from the plane to the beginning of the runway and determine how high the plane is flying in the air. So from here to here, from this part to this part, is going to be 12 degrees. Looks like 120. It's 12. And from here all the way down to the initial line of sight would be 15. So again, this is a line that is parallel to the ground. So if this is 12 and this is 15, that leaves us with 3 in this region. Okay, now think of this as a transversal here. We have two parallel lines. This is a transversal. So this is 12 degrees, and that leaves here with 12 degrees. Again, this is a transversal cut through these two parallel lines. So if this angle is 15, so is this angle. Now I do have a right triangle here, so I know that these two angles have to add up to 90. If I take 90 and subtract 15, I end up with 75. And now I can easily figure out this angle because I have two other angles. So I know that 12 here plus 3 is 15, and I can take 180 minus 15 to end up with 165. Alright, so now that I've set it up, let's go ahead and let's figure out this distance for this line of sight. Okay, so I am provided with this angle and the opposing side, so the sine of 3 degrees over 165 is equal to, we want to know this length across, so the sine of 12 degrees across from, and I'm going to call this length C. Let's cross multiply to get C times the sine of 3 degrees is equal to 165 times the sine of 12 degrees, the sine of 3 degrees, the sine of 3 degrees, and if C is equal to, let's grab this, and then we're going to have to make sure that it makes sense within the context of these problems. Okay, let's divide by the sine of 3. Oops, let's see, make sure I wrote that down right. Make sure I have the sine of 3 over 6,000. Oh, that's where I did wrong. I meant to put 6,000 here. 6,000. That was my mistake. So this should be 6,000 here. Sorry, let's go 6,000 times the sine of 12 divided by the sine of 3. Okay, so I have 23,835.8 feet. And that's going to represent its distance of the line of sight to the beginning. Alright, I'm going to go back and I'm going to look at this triangle knowing I have a right triangle. This is 75, this is 15, and I know this length is 23,835.8. And I want to know what is this length. Okay, so what can we do now? Let me push this paper up. Okay, I am going to choose to use one of our primary trig functions. So opposite over hypotenuse. So I'm going to choose to do the sine of 15 degrees equals the opposite over the hypotenuse. Now to isolate that x, we'll multiply both sides by this length. And I'll isolate the x. Okay, here we go. So I have that amount, and I'm going to take it times the sine of 15 degrees, and I end up with a length here. The height at this position above the ground would be 6,169 and we rounded 0.2 feet above the ground. And this would be the distance here.